Well, hello. It's another day with Audrey and another week. Can you believe it? Next Sunday is the beginning of daylight savings times and we will be losing an hour of sleep. Do I hear a collaboration of boos? Yes, I know I do. All right. So, welcome on in. Hello, Alicia. Hello, Jennifer. Hello, blah, Blaine. Sorry. Hello, everyone. Coco. All right. Gloria. Hello. So, what we're going to be working on. So, I figured we're not just going to kind of ease in here. Hello, Jennifer. Hello, everyone. Hello, film artists. Nice to see you again. So, we're here. Good afternoon to you. I kind of missed you guys, but I felt like, you know what? We're going to have to take a break from each other once in a while. You know, it's great to learn math, but we all need a little bit of a break. So what we're going to be learning today is we're going to hit on some exponents, and if time permits, we're going to look at scientific notation. Okay, so what to do when you have those, as we all like to say, really big numbers, and what we're going to do. Hey, Air Force girl, thank you so much for the follow. So, as I'm going to see if I can zoom in, and as you haven't noticed, the book is back. I finally got my new book. So now I can kind of do on here, and I changed up, Okay, we still have the original book. Don't worry about it. We still have this one, but I also have this as a cover. So I just want to show you that there is more than just one cover. It's not someone trying to copy my stuff. It's me, okay? We all like a little variety in our lives. All right, so if you take a look, these are going to be the rules and basically the properties of exponents. So if you want to take a screenshot, you can take a screenshot. I definitely want you to understand, because if you don't understand these rules, it's really going to be hard for you to do factoring. It's really going to be hard for you to break down radicals. It's going to be hard for you to break down rational functions, which eventually I'm going to touch on. So everything has its place and its spot. So when we look at it, we know that when we multiply, and only when we have the same basis, okay, let me kind of take it to the side so you guys can take a quick little snapshot. All right, so when you have the same basis, okay, when you're multiplying, either you're seeing a dot or parentheses. When you multiply and have the same base, you're going to add your exponents. Okay, so let's say, for instance, I have a base of 3. So I say 3 raised to the second power times 3 raised to the fifth power. Okay, so when we are multiplying and we have the same base, we have to add our exponents. So 2 plus 5 will give me 7. So it'll be 3 to the 7th power. If you need to extend that, this is what I have to emphasize. 3 to the 7th power does not mean 3 times 7. No. Okay? No, we're not doing that. Okay? What is happening? It's telling you that you have a base of 3. Let me slide this over and I'll slide it right back for a second. You have a base of 3, and that base is being multiplied, not added, multiplied to itself 7 times. I think I need one more. Okay, so you know that's a heck of a lot bigger than 21, okay? But when you get any kind of test, regardless if it's a classroom test or if it's SATs, ACTs, GED, whatever you want to call it, no matter what, they always have 21 as one of the options, because that's exactly what everyone does. Okay, everyone always like, oh, it's 3 times 7. No, 7 is an exponent. 3 is your base. So your exponent is saying, hey, you need to multiply this base this many times. Okay, so we really got to emphasize that. So when you are multiplying and they have the same base, you add the exponent. Now, if I have, let's say, 4 to the 5th power, I don't know about me and fives, and 3 to the 2nd power, okay? I can't combine those. Why? Why can I not go ahead and just multiply them? Why can't I just say, oh, my answer is 12 raised to the 7th power? Put it in the chat. Thank you, everyone, for coming in. Yes, this is a participation type thing. And thank you for the likes. Let's go. Teach us, not a problem, not real, but you are real. I see you, unless I'm really messed up. Not a problem, because the base is not the same. Thank you, film artist. Stargazer, hello, the bases are different. Yes, divinely wise. Yes, we cannot, because our bases are not the same. So we can't just simply multiply the 4 and the 3 and add the 5 and the 2, okay? Is it because of two different numbers? Yes, love Lola. All right? Okay? In order for you to multiply and to do that adding of the exponents, my bases have to be the same. All right? So, hey, Jalen. All right, so that's the multiplication one. Let me slide over. Then, for the division. Division is simply a fraction, right? It has a to the m divided by a to the b. So again, we have the same bases. So when we're dividing, we're actually going to subtract the exponents. So here we are. They have the same base. When you're multiplying, you add the exponents. But when you're dividing, you subtract the exponents. And where do you start? You start at the numerator, okay? You want to start up at that numerator. So if I have, let's put some variables in here. I don't know if me and 7. I'm like doing 7, 6. Let's just do a 5. Let's do a 4 here. Let's do a 4, and let's do that as a 1. All right. I was on the other one. Why you can't multiply? Because for these, I can't multiply unless I change it from 4 to the 5th power, because that means 4 times 4 multiplied to itself 5 times, which will give me 1,000. Okay, don't be impressed. I just looked in the calculator. 1,024. And then multiply that by 3 squared, which gives me 9. Now, right away, nowhere near 12. Okay, nowhere near it. So if I have that times 9, this will give me, 9,216. Yeah, nowhere near. Nowhere near. So the trick is, it has to be the same base. Okay, Gloria? They have to be the same base. Okay, that's the only way that you can do this. Here, I have a base of 3, base of 3. So that means I continue on the base of 3, and then I add my exponents. How did I get 1024? 4 times 4 times 4 times 4 times 4 times 3 times 3. This is what's happening up here. Okay, you see it, Jenny? Okay, your 4 is a base, and you're multiplying. So you got 4 times 4. That will give me, I have a 16 here, I have 16 here. Okay, so 16 times 16, that gives you 256, because that's a perfect square. And then 256 times 4 will give us our 1024. Okay. All right, Christopher. Always do that. Yes, everyone does. So that's why I want to emphasize that here, okay? So, okay, good. So if you're trying to add the exponents, and trust me, that 12 raised to the 7th power will be one of the options on the test. Every time. Every time. And I bet you people pick it. Every time, right? Okay? So when you multiply, you have to have the same base. Okay, same base, add the exponents. So now we're going to divide. So when we divide, we have y to the 4th divided by 1y, or y to the 1st power. This is basically saying, let me extend it so we can see it. I am multiplying my base of y 4 times because it's y to the 4th. And I'm putting it over 1y. Okay. Thank you, Melissa. I appreciate it. All right. So if we take a look, we have 4 y's, we have 1 y. If I say a number divided by itself equals 1, so this is going to give me an option of 1 whole. What's left? Oh, thank you for the follow. What's left? How many y's are left? Okay, y to the 3rd. There's 3 y's left. Okay, y to the 3rd. Hey! Maria, good. Y to the 3rd. Hannah, yes, there's 3 y's left. This Tuffy, yes. Y to the 3rd. Good. So, what we did was subtraction. This is exactly what you did. You had y to the 4th minus that 1y that was in the denominator. So, that means you have y to the 3rd. So when you divide, you're actually subtracting your exponents. Okay? When you divide and they have the same base, you're subtracting your exponents. Okay? Yeah. So when you see it as an extension and you see that, oh, okay, I can get rid of this and get rid of this, that'll be 1 whole, then I ask myself, okay, how many are left? And 3 are going to be left, right? So if I say, playing devil's advocate, I'm going to put over here. So if I say x squared over y to the 4th, can I do that same trick? Hey, Sophie. Can I do the same trick? Okay. Hey, say no. Hey, no. Joe, how are you? No. Shay, no. This Tuffy, no. Maria, no. Not sure. Hey, not sure. Not like terms. Good, Shay. Okay. So, unlike, let me unzoom just a hair or a lot. Like, sometimes my zoom just gets a little cray. All right. We had the same variable, which was y's, right? So once we extend it out, and I'll even extend it out over here, this means x times x, okay, over 4 y's being multiplied by itself. Now, just like how we did here, we were able to eliminate the 1 y's because we had one set of y's that would give us 1. And then we had 3 y's left over. But over here, do we have anything to cancel out? Is anything the same? Okay. Oh, thank you. All right. No. Right. Why are you waiting for the answer, Jasmine? You don't have to wait for the answer. You know what the answer is. So we don't have anything to cancel out. So if we don't have anything to cancel out, we cannot do that subtraction. This is at its lowest term. This is the answer right smack there. There you go. All right, good. All right. So you have to have the same base when you're doing when you're dividing, you're subtracting the exponents. All right. So that was multiplying. Literally have a test on this Thursday. Oh, good job. Perfect timing. Can we rewrite it as a negative exponent? This one, no, you cannot, because they're not the same base. Okay, they're not the same base. Don't mix, right? Can't mix it, okay? Gotta keep it simplistic. All right, so that's dividing. Multiplying, same base, we add the exponents. Dividing the same base, we subtract the exponents. Now, here, let me shift over and zoom quite a bit. Okay, so if you don't have this section of the formula, go ahead and screenshot it. I'm perfectly fine with sharing with that. To come back later, thank you so much for this. Not a problem, Gloria. Thank you for love. So, right now we're here. We have a raised to the m, which is being raised to the b. Okay, so we're looking at this part right here. So if you notice, anytime there's a parenthesis involved, that means we're multiplying the exponents. Okay, we're multiplying those exponents. So this is what's happening. Let's see if I can. Yeah, we're good. So if I have 5, oops, got a little excited. If I have 5 squared, and I want to raise that to the second power. Okay. So this is saying, and remember, PEMDAS, we want to work from the inside out, work inside that parenthesis. So that means inside this parenthesis, I'm going to take it step by step, I have 5 squared, and 5 squared means 5 times 5. Then this outside exponent is right here. So now they're saying, I want to do 2 groups of this parenthesis. So it looks like this. I have 5 times 5, that's one group. Then I have 5 times 5, that's another group. Let's see if I can raise up a little bit. Okay. Do I have a YouTube channel? Yes, I do. Okay, it's under my name. So we got Audrey Codner. And sometimes ACG, math tutoring. Okay. Do you FOIL? You don't really have to FOIL. Okay? You don't have to FOIL. Yeah, but what I meant was that it could be written. Okay, but why? I'm not sure where you're located, but in the States, we don't like to have negatives in our solutions. We always factor out negatives. We always get rid of the negatives as our exponents. Okay, but I know some areas are perfectly fine with that, but I know here in the States, we do not. Okay. All right, and especially IB. Now, what you basically did was we started off with 2 5s. That's what was inside the parenthesis. Then we had to square our parenthesis. So that means this was 1, this is 2. How many total 5s do you see? How many total 5s do you see? Okay, that'll be the solution, but how many total 5s do you see? Oh, thank you, Blessed. Okay, so we got 4, 4, yes, 4. Get rid of the question mark, you got it. Okay, so we have 1, 2, 3, 4. Okay, we have a total of 4 of those 5s. So we have a base of 5 to the 4th power. Okay, remember, our exponent is telling you how many times you need to write out that base. So we write out that base. The base is appearing 4 times. The base is 5. So the reason why this rule is in existence, when you have a power being raised to a power, you multiply the exponents, because 2 times 2 gives us our 4. Okay? So even if and yes, my solution will be that 625. Yes. Okay? Yes. So my answer is 625. But I want you to see where these exponents are coming from. Because I think that once you see where this stuff is coming from, then you'll be able to connect with it a lot better. Now you won't be so afraid of it. Because I don't think a lot of people tell you why. They just say, here's this thing. Just know that this raised to this equals this. Boom. Just memorize that, right? Okay. So we're showing you. So if anything, if I did a to the a cubed raised to the 4th power. Okay. So it's telling me a cubed. That means inside I have a times a times a, because that's what a cubed is. And that's being raised to the 4th power. So that means my parenthesis is basically being written 4 times. Okay, so I'll have my a times a times a. Okay, so now, yes. Okay, yes. So that means we have 3, 6, 9, 12 of those A's. So that will give me a to the 12th. Okay, good. All right. So instead of you doing this huge extension, it will be nice and easy for you to remember that if you have one base, a power being raised to a power is just simply your base, the exponent, times the exponent. So that will give you a to the 12th. Okay, you get the same answer, but condensed. So much condensed. All right, so I'm going to keep going. If you know someone that's taking their GED, that's taking the Accuplacer, thinking about going to the military for the ASVAB, or just struggling with algebra, maybe you're a homeschool kid that's like, I'm doing this by myself and I hate it. And you notice that this is being helpful, go ahead and share it out. Mention it to the people, mention it to your friends. Because I want to keep doing this, but if I don't get that much, I'm going to have to shut it down, and I don't want to do that. Hello, Miss LLP. Okay, you love algebra. Awesome. This is similar to scientific notation. You're going to see it, because scientific notation is the next part. Yes, and geometric. This is very helpful. Good, good. Because I want it to be helpful, but at the same time, I want people to share it out. I don't, I love that people are coming back, which is awesome. But I want to spread the word. Then I'm here to help. Okay? All right. Scratch geometry. Okay. She's like, no, scratch that. She's like, I love algebra. Nope. Take that out. Okay, you're taking intermediate algebra. Good. Okay, how's it going? Because I know there's a lot of people that are going back to school and they're really trying to understand these concepts. All right, good. And let's go back to our list again. So again, we'll go back to it. I think, there we go. Whoa. Again, my Zoom's a little crazy. So when you're multiplying and you have the same base, you add your exponents. When you divide, you have the same base, you subtract your exponents. When you have a power being raised to a power, aka is there's a parenthesis in between the two exponents, you're multiplying your exponents, right? So now, here's another way of seeing a power to a power, okay? Okay, and statistics, okay. Hanging in there. Okay. Yeah, I know. Especially those classes. When you take college classes, they are going to go by fast because you only have like 7 to 10 weeks to learn almost a whole year of algebra. I think it's always a setup, but that's just me. So, let me say for example. Okay, let me put this bad boy in pen. I feel like being dangerous. Dangerous! All right, so she's like, oh, she's writing in pen and doing math. Sacrilegious. So let's say we have 2/3 and we have, we'll just say, I'm going to put a 2 there. All right, so we have 2x squared divided by 3x, and it's raised to a power of 3. Okay. Yeah, I totally believe it is set up. I'll share my 2 cents in a moment. So, what is happening? Yes, I see a power being raised to a power, but now we got coefficients involved. Now we got some other stuff going in here. So if I can break this down, let's work on the numerator first. So let me cover up my denominator just for a moment, just so we can focus on the numerator. So I'm basically saying everything inside this parenthesis is being raised to the 3rd power. And this is what gets a lot of students. You're like, okay, well, my x squared is being raised to the 3rd power, and I just learned that. That's awesome. Okay, I can do that. And then they'll just bring the 2 down. Okay? This is where a lot of people go wrong. Everything has to be raised to the 3rd power, including this 2. Okay? Everything has to be raised to the 3rd power. So the 2 is being raised to the 3rd power. The x squared is being raised to the 3rd power. Everything for that numerator is being raised to the 3rd power. Okay? Thank you for the rose and the gifts. I appreciate it. All right? Okay, mind blown, right? So many people probably got a problem wrong because you forgot to distribute that cube to everything. So now I'm going to slide it up, hide up the top. I'm going to show the whole thing in a sec, but I like to show it piece by piece. So this 3x is also being raised to the 3rd power. So that means the 3 is being raised to the 3rd power, and the x is being raised to the 3rd power. Okay? Everything is being raised to the 3rd power. I don't do statistics because I hate it. I'm sorry, Kimmy. But if you do need somebody, I do have some friends that do tutoring for statistics. I always say, I got a guy. So if you're serious with it, go ahead and DM me, and I can definitely connect you with my person. Yeah, statistics. I know. I know. You would think, oh, statistics is easy. Yeah, then you got the Z scores and the T scores. And yeah, no. All right, so now let's get to this. 2 to the 3rd power. What is 2 to the 3rd power? And don't say 6. Okay, I can do trig. I can do trig pre-calc I feel comfortable with. But calculus, my same friend can do that. Good. We got 8. We got 8. We got 8. We got 8. We're crying. Why are we crying? Are we crying with laughter? Like, I got a guy? Okay, good. We got 8. Yes, because I know somebody's going to want to say 6. It's not 2 times 3. It's 2 times 2 times 2. Okay, so this gives us our 8. So now think about what we just did. Okay, x squared raised to the 3rd power. Think about what we did up here. Here's a little hint. Use it as a guide. So this will be x to the what power? Okay, I got 6. I got a -1. How are we getting a -1? Then I got 6. I got 6. I got x to the 6. Okay. All right. So we got x to the 6th because, remember, just like how we did here, 3 times 4 gave us our 12. 2 times 3 will give us our 6. Okay, sorry, x to the 6. Okay, good. All right, questions before we get to... Okay, yes. So when you see a power being raised to a power, you multiply, not subtract. You only subtract when you're dividing. Okay. All right. So now, denominator, 3 to the 3rd power. What is 3 to the 3rd power? Don't tell me 9. Good. Love it. Hey, Em. Yes. Good. Good, Joe. Good. Yes. We got my 27s. Good. Good job. There you are, Alicia. Thank you. All right. Now, x to the what power? Okay. Good. I got one person. Good. 3, 3, 3, 3. Yes. X to that 3rd power. Good. Yvette, yes, it is 27. Good. So now do your x. X to the... Okay, good. Good, Elliot. Jalapeno pepper. Oh, that's cute. All right. So now we got this. And you're like, okay, Audrey, yay, we did it. We're done. Okay, that was my exponent answer. The 27? Because since it's x raised to the 3rd, for the 3 raised to the 3rd, that will give me 27, because that's 3 times 3 times 3. X to the 3rd will give me x cubed. All right. Okay. Yep, we're not done. Ultimate Emo, how are you? All right. So I thought was 9. You thought was 9? No, because 3 times 3 gives me 9. That's not what this is saying. It's 3 times 3 times 3. Okay. All right. So now, look. 8 and then 27, we're going to keep that. What about our x's? Okay, thank you. What do you think we're going to do with our x's? Not our x's. Our x's were like, yeah, we're done. There's no going back, people. Just stop going backwards. Okay, stop recycling. Move on. Okay, we're not going to cancel. Okay, yes. Who said it? Loris, we got... Okay. Is it Parita? Okay, so we're going to divide. So Yami, hi Yami. What are we doing with our exponents? Okay, good. Okay, good. So we're going to subtract, because anytime we're dividing, anytime you see this fraction bar, that means we're dividing. So that means we're going to subtract our exponents. So it's going to be 6 minus 3. So if I look, I'm going to have 8. Then I have my 27. 6 minus 3, not to insult you. But what's 6 minus 3? I know, I'm digging deep here. She's like 3. I know, everyone's like second guessing themselves, like 6 minus, is it 3? It's so simple. Is it 3? I'm like, yeah, it's 3. Okay, so not a negative 3, because we're not subtracting the denominator and the numerator. We always start at the numerator. Okay, so numerator minus the denominator. So that gives me 3. So here's the trick question. Where would my x's go? Not my x, because he can go H-E double hockey sticks. But anyway, but where can my x in the problem, where would it go? Would it go in the numerator or in the denominator? Oh, sorry. Thank you. Okay. Would it be in the numerator or in the denominator? Okay, I got 3 votes for the numerator. 4 votes for the numerator. 5 for the numerator. If you don't really feel like typing out the whole word numerator, just make it S. Because it's not a negative. Okay, no. All right, good. So you have 3 left over on the top. Good, user. Thank you. Okay. So here you have 6 over 3. So if I write it out, let me write it out up here. So I have 6 x's. And then I have 3 x's down here in the denominator. Okay. So if I want to cancel out, this will give me 1. This will give me 1. This will give me 1. They cancel out. How many are left? 3 are left. And where's the location? In the numerator. So it will be x and 3. Okay. The only time this will be a negative is if the larger power is in the denominator and the smaller power is in the numerator. Okay, that's how you would get a negative. All right, well, thank you. That was helpful. Yes. All right. So this is your breakdown. That's your answer. And I know you're going to have an urge of like, oh, I got to reduce that. Well, if you reduce it, my loves, that means you're going right back to the beginning. Okay? We want to see these numbers being cubed. That's where the 8 and the 27 is coming from. Okay? So everyone's so obsessed with like breaking down because you had a teacher that says, you got to break down. You got to break down. All right? So you got or you got to break it down. You got to break it down. You got to simplify it. And you got it drilled in your head. But if we started with the simplified number and we're cubing it, that's why we're going to keep it as the 827s. Okay? So solve it, leave it alone. Just leave it alone. Just put the pencil down. Just, I don't want to say throw the pencil across the room because that would be you throwing a fit. All right. All right. You could wrote that as a coefficient for x cubed. I could, but then it's taking me right back to the beginning. They want to see this. Okay. That's why we're cubing it. Leave it alone. I love Linda. Leave it alone. I know. We want to do so many things. Okay. Why doesn't the denominator take the exponent and the numerator does? Okay, going back to this. We had 6 of the x's being multiplied up top. We have 3 of the x's being multiplied down below. So if we cancel out, okay, this will give me 1, this will give me 1, this will give me 1. How many x's are left and where are they located? Okay, so you have 3 x's left and they're located in the denominator, in the numerator. Got me saying it. Okay. Yeah, okay. All right. Well, these are great questions because I just have a weird feeling that you've always wanted to ask these questions in class, but you were afraid to, right? So I'm really glad that you guys are finding this as a safe space and we're actually getting things done, which is awesome. All right. Oh, hello, Ann. Yes, thank you so much for the follow. Can you explain how to break down the x's? What do you mean? How to break down the x's? This needs to be a video. Well, actually, I have it in my course. So it is a video. So if you ever want to purchase my course, you can go to my website. Go ahead and just fill in the information and then we'll just reconnect. Okay? All right. So we did the multiplying. We did the dividing. We did multiplying, well, raising a power to a power, raising a power with a number. Was it denominator? Right? Was it denominator? What do you mean? Where the x's go? The x is going to go in the numerator. Okay? You have 6x's, 3x's. 6 minus 3 gives me 3. There's 3 x's left in the numerator. Okay? Can you screenshot as soon as I'm done? Because we're not done. Okay? So might as well just do one screenshot so you can have everything. All right. Now, we're looking at when you have a negative exponent, just like that one gentleman, that can't not live without that negative exponent. All right, so, so we have, let's say, let's say 4a raised to the negative 2. So we can double, we can triple, but it's hard to do it when there's a negative. So that means I'm dealing with smaller numbers. So when I'm dealing with smaller numbers, that means I'm dealing with numbers that's less than 0. That's less than 1. So well, actually not 0. That's less than 1, but greater than 0. There we go. So we're looking at those fractions. We're looking at those decimals. But doing decimals with exponents, yeah, it's cray-cray. It's really cray, okay? And I'm going to show you later on how we can actually do that. So with the 4a raised to the negative second power, that means I need to change this whole number into a fraction. So by the act of making it into a fraction, that means this whole thing of 4a is going to come down in the denominator. But by the act of moving it down to the denominator, my exponent is going to be positive. And like I said, we got to make this into a number between 0 and 1. So we need to make it into a fraction. That's why we're going to put the 1 in the numerator. Oh, thanks, Joe. Oh, good. Just not from you. Oh, it's okay. It's gonna be all right. All right. So, anytime I have a negative exponent, I'm in the whole number type of world. That means I need to talk about the world that's going to be between 0 and 1, those fractions. So I have to make this whole number into a fraction. And by making it into a fraction, I'm making my exponent positive. So if I may, we have our 1 over, and now let's practice up. So it's 4a squared. What should I write as my denominator? Okay, so Britt, hello Britt. So Britt's saying 16a, something's missing, Britt. Joe's saying 16, something's missing. Let's put it this way, I agree with the 16s. I agree with the 16s. Dawson, hello Dawson. Maria, yes. Austin, hello Austin. Okay. So Stephen, yes. Stephen Keith, how are you? The best, yes. Oh, Beep Boop, how are you? I haven't seen you in a minute. Okay. So we squared the 4. 4 squared gives us 16. And we square the a. This gives us a squared. Okay. Good. Sleeper, good. Okay, just got home from class and got stuck on a problem with the exponent. Now I can go finish that. Yes! Good job. So glad I can help. Okay, so that's when you have a whole number being raised to a negative exponent. So now I'm going to play devil's advocate. Ooh, she's on the edge, man. She's on the edge. All right, so what did x with to get 16? Try again. What did x w to get 16? What did x... Dolores, can you help me out again? Like, how did I get the 16? Can't see the answer. Answer's right here. Okay. What did you times? Oh, okay. Thank you. To get the 16. So this is the same as saying 4 squared. And this is the same as saying a squared. So 4 squared is not 4 times 2. 4 squared is 4 times 4. That's how we got the 16. Yes. Thank you, everyone. All right. Okay. All right, so I'm going to slide over. Are you okay now, Dolores? I thought it was 2 times 2 times 2 times 2. Nope, our base is not 2. Our base is a 4. Okay, so with our base being 4, it's being raised to the second power. So it's going to be 4 times 4. Okay. If it was 2 was my base and 4 was my exponent, that will be 2 times 2 times 2 times 2. Okay. So you're thinking correctly, but you switched it around. Problem above. Oh, okay. Well, wait a second, because we're going to keep going. All right. So now, what happens if, and I'll put this in red, what happens if my negative was in the denominator? What happens if we have 1 over 2x raised to the negative third power? Okay, good, Dolores. Okay. What do you think you would have to do this time? Think about what we did last time. Okay, so user saying I switch. Okay. Is it user cute? I'm trying to get on there. Okay. All right. So Maria, where would it go though? Would it stay in the denominator? Okay. And then Bridget, hello Bridget. Okay, flip the fraction. Yes. Okay. So if we start off as a small number between 0 and 1, that means this negative is saying it needs to be a whole number. So this is basically the same as saying 2x raised to the third power over 1. But we don't need that over 1 because we know it's a whole number, right? So all we have to do is cube the 2. So remember, 2 cubed is not 6. It's 2 times 2 times 2. Which a lot of you guys are saying is 8. And then x to the third power will give me x cubed. Okay. Good. Good. We need to flip it. Yes. Okay. If it's positive in the bottom, if I flip it, would it be negative? No. You don't need to flip it. The only time you flip is when you have a negative exponent. Good question. Thank you, Amelia. I had to jump for a conference call. Okay, I missed the last problem. Okay, I got you. Definitely need this refresher to learn again. Wasn't my strong subject in school. That's fine, Alex. So I'm here. All right. So if we, let me see if I can shrink a little bit so we can get this. So the original was 4a raised to the negative 2. Anytime we see a negative and it's a whole number that's inside the parenthesis, that means we need to make this number into a fraction or a number between 0 and 1. So we're going to put the 1 over top, and by the act of us moving this whole number down to the denominator, it makes the 2 positive. Okay? So then from here, we're going to distribute that square to both the 4 as well as the a. So 4 squared, that's where the 16 came from. A squared, that's where the a squared comes from. Okay? It's kind of like KFC. It is kind of like it. But I don't want to confuse the two. So that was that first one. So now for the second part, I said, well, what happens if the negative is in the denominator? So we got 1 over 2x raised to the negative third power. So that means we're saying this fraction, needs to go into a whole number. So that means this needs to move up to the numerator. So instead of a negative 3, it's a positive 3. And it can be like over 1. So basically like flipping it. But we don't need the over 1 because it's already a whole number. So that means it's going to be 2 to the third power, which is 2 times 2 times 2. That's where your 8 came from. And then your x cubed comes along for the ride. Okay. Gotcha. Good. Okay. All right. And the last property. You're probably like, this is just for the properties? I'm like, yeah. So for the last property, which is the easiest one, okay? Now, will you always flip? You only flip when you have a negative exponent. If you don't have a negative exponent, you don't have to flip, okay? So the easiest one, which is the last one, and the last one says that anything raised to the 0 power is 1, not 0. Stop it. Okay, anything raised to the 0 power is going to give you 1. Okay, that's huge. There's going to be, I remember I had a final in college many, many moons ago. And this was one problem. Like, I'll tell you how old I am. It was on chalkboard, okay? So I walked in and I saw this monstrous of a problem. It had radicals, it had fractions, it had exponents, positive and negative exponents, it had like decimals in it. Like, it, just think of every single solitary number you can think of. It was in this problem. And it went from one end of the room to the other end of the room. And I was like, I'm going to be here forever. And he said, we walked in, we sat down. He's like, okay, ladies and gentlemen, here's your final. And we're like, what? And literally it was like one problem. And I was like, yeah, but this is going to take an eternity. And I sat there and I looked at it, and internally I cried. But then I noticed in the beginning, it had, I'm just going to give you like a mere sampler, I think. Okay. In the beginning, it had a bracket. And when I said, like, it had fractions, it had radicals in here, it had like improper fractions, it had decimals, all kinds of craziness, right? But I noticed there was a fraction, or there was a bracket in the beginning. So I'm like, okay, well, where's the end of this bracket? And I followed from one end of the classroom all the way to the other end of the classroom. Ridiculous. Like, this man had no life. Like, seriously. And I noticed the whole thing was raised to the 0 power. All of that madness, everything was raised to the 0 power. So my answer was 1. And we were supposed to hang out, you know, I had my friend Jenny from Jersey, and I noticed that, and I wrote on my paper equals 1. Like, I wasn't copying all of that. Like, no, like, forget that. And I gave him my paper, and he just looked at me and he says, all right, have a good year. I'm like, thank you. And then everyone's looking at me, giving me the stank eye, like, how does this trick get out of here before me, you know, because there was some egotistical people in your classroom. We all have a good 5 in our classes. And I was waiting for my friend Jenny. I love Jenny. I have to see where she's at. And she's like, oh my God, like, how? This is how she talks. How did you finish so fast? Like, what in the world? And I'm like, Jenny, the whole thing was raised to 0 power. She's like, what? I will never forget. She looked at me like I shot her dog. Like, that's how sad she looked. And I was like, go inside and see if you can change your answer. Hurry the hell up, because I want ice cream. So, I always tell, yeah, that was a method to the madness. Yes, well, I would have felt these problems. Yes. Oh my God, I have to wonder where Jenny is, because she just always cracks me up. She's like, this is not the answer. Hilarious. Yeah, so anyway, anything raised to the 0 power is not 0, it's 1. Have it ingrained in your mind. Think about it. Anything in life has to start with something. Okay, before we were a thought, there was a sperm and there was egg. Okay, there was something, right? Before it all, the osmosis and blah, 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 blah. All right? So everything has to start with something. So if you're at the 0 power, you have to start with, let's say we have to start with you. Okay? All right. Awesome. Questions. I have questions about my mentality, but we're going to talk about something else. Incredible smart to zoom out and see the brackets. Yes. All right. So let me... Woo, wrong one. So I know a lot of people want to do like a screenshot. So I'll come here. So at least you can get this. I think we might have to do like a couple. So just let me know when to raise up. So the first one is when we were multiplying. Maybe I might put a little hold on for a second so you can organize this. 1 second. Okay, so this one was the multiplying. This one was the subtraction. Just so your eyes can follow it a lot better. Power to a power. There. Raised with the negative exponents. And when it's equal to 0. Okay. So instead of me putting lines, just each of the boxes is representing each of the properties. Okay. I forgot what our brackets again is the same as multiplying. Yes, it's the same as multiplying. Yep. So first you got your parentheses, and if you need to have a parenthesis, instead of double parentheses, you can use a bracket. Okay. Right. Oh, thank you. I always told that story to my students, and especially when you're in the classroom, I can actually show them like how long the problem was. Trust me, if you go from one end of a classroom to the other end and include the side classroom board, forget about it. Yeah, I would have cried. Everyone, like literally, I was like, I'm going to fail in life. All right, good. All right, do I need to push it up so people can get the bottom part? Because sometimes, all right, thank you. I appreciate that. So I'm always here. Okay. All right, so I'm gonna give you one problem. Okay, so I can go a little longer today because I do not have a student. So that's why we're gonna do 2 things today. So I'm gonna give you a problem, and I want you, well, maybe we'll do a problem together, and then I'm gonna have you do a problem yourself. Okay, so have your notes ready. Okay, I'll talk about my notebook in a moment before I go to the next subject. I'm going to use my clip so I can flip so much easier. All right, so let's do a problem. All right, so we have, let's see. Okay, we can do this one. So we have, I think we can see it. All right, we're good in line. So we have 2a squared b cubed. Oh, she's getting fancy. It's all right. Squaring it. What? Breathe. I can sense the panic. Oh, wait, hold on. I have to do this thingy. The puzzle piece with the slide. Okay, here we go. I mean, I get the whole puzzle piece thing, but sometimes it's a bit annoying. Okay. Over. Oh yeah, you thought you were done? No. A cubed b squared. Ooh. Okay. Okay. I'll flip back over in a moment, Dolores. Sorry, I just saw your message. Okay. I don't know where everyone's from, but Mother Nature is so disrespectful. Like, it was like 30-something degrees a couple days ago. Now she's trying to make it 60. Girl, you having a hot flash? What's going on? I can't take this temperature. Moody, hello. How are you? Always a pleasure. All right. Lunch break. Yeah. Yeah, we're doing some exponents today. We just went through the whole properties. I broke them all the way down. All right. So, Mr. Pretty Flacco. We got 4ab to the 4th. Let's see. Okay. Thank you so much, guys, for the likes. I appreciate it. Okay. Thank you, Elizabeth. Appreciate it. Hey, Tia. Is it Belize? Welcome in, everyone. All right. Father Swaggy. He's saying 4ab to the 4th. Okay. Okay, remember, take your time with it. Use your notes with it. Okay, so in conversation, we got 4a to the 4th, b to the 6th over a to the 3rd, b to the 2nd. Okay, so you're almost there. Don't forget what we do when we divide. What do we do when they're the same bases and we're dividing? Yes. Thank you. Good for the help. Love it. Love it. I love it. Okay. Okay. Guadalupe. I was showing. Oh, okay. So check your a to the 3rd. Recheck your a to the 3rd. Okay. All right. Are we close to the big reveal? I also accept question marks. So if you're like, yeah, Audrey, yeah, it's just going to be A. There you go. Do you give any tutoring classes? Yes, I do. Yes, I do. Just go into my profile. You can go to ACG Math Tutoring, and there's a contact form in there. So just fill that out, and I'll give you a call. Actually, sometime today. My neighbors want to blow their horns. They're celebrating. I don't know. They're just being annoying. All right. Ready? Ready for the big reveal? Yes. So if you know of anyone else that needs assistance with algebra, that needs assistance with their GED, AccuPlacer, ASVET, or just like math in general, you might be doing something. Oh, thank you. Get my GED. Okay, gotcha. Well, I need a tutor for ASVET. Awesome. Definitely contact me, okay? Because if we get enough people and we do need to do like a study group as opposed to, and I like to keep my group small. When I say a group, I mean like literally a group of 4. And if I have to do multiple ones, I'm more than willing to do that. But I just need to know. I'm sorry for the absence. Today is busier than... Not a problem. Trust me, it is Monday. Like, I get it. The fact that you're trying to fit this in, it's like, I get it. Okay. All right. So let's break it on down. All right. what I like to do is I want to basically distribute this square to everything in the numerator. So that means the 2 is being raised to the second power. The a squared is being raised to the second power. And the b cubed is being raised to the second power. I have to shrink a little bit. A little shrink-a-dink. There we go. All right. And all of this is going to be over my a cubed and my b squared. Okay. So I'm going to go lengthwise. So now, actually I'll slide over this way. So 2 squared, that's 2 times 2. All right, so 2 times 2 will give me our 4. Now, a squared raised to the second power. That will give me a to the what? Put that in the chat. Okay, a squared raised to the second power. That will give me a to the what? Okay, so definitely, Dolores, definitely like fill in my information off of my website so I know, because sometimes I don't see, as you can tell, sometimes I don't see all the and remember, because as soon as I leave out of here, I got to get myself together for tutoring later. Good. To 4th power. 4, 4, 4, 4, 4. Love it. Now, b. So we got b to the 3rd power being raised to the 2nd power. So that means I got b to the what? Amelia already knew what I was going to say. He's like, girl, I got you. I got you. Okay. Wanya. Good. So make sure you're not, is it Yuri? You're not raising the 3 to the 2nd power. It's actually going to be 3 times 2. Okay. So it's going to be b to the 6. Multiplying, not subtracting. Multiplying. So 3 times 2, that will give me 6. Okay, good. Oh, hey, Holly. It's been a moment. How are you? Okay. So now, there you go. So now we're going to rewrite our denominator. So we have a cubed, b squared. All right. So what do we do? Good. So what do we do when we're dividing? What do we do with the exponents when we're dividing? Nice when top number bigger than bottom. Yeah, it is nice when its top is bigger than bottom. Life lesson. Okay, so we're going to subtract the exponents. Good. So we're going to keep that 4. That's in our numerator. Okay. Then we have 4 minus 3, which gives me 1. So that means this is just going to be an A. And then we have b to the 6 divided by b to the 2nd. So it's 6 minus 2. So that gives me my b to the 4th. Okay. I try, Amelia. All right. So this is what happens, okay? I like to break it down. Yes, I like to break it down so you can see it. Eventually, when you get comfortable, all the stuff that we have right here is going to disappear. Because you're going to be like, all right, 2 squared, boom, 4. Okay, a squared raised to the 2nd. Okay, I multiply a to the 4th. B to the 3rd raised to the 2nd power. Okay, that's b to the 6th. And you're going to get used to it, okay? It does. It is. It is. But see, my thing is when you learn this for the first time, sometimes you just don't have time for it to marinate. You're worried about, am I going to look stupid? So you worry about that one. Am I the only person that's not getting it as quickly as everyone else? Then you're comparing yourself to the nerd in the class. Then you're comparing yourself to whatever. And it's like all that pressure. Okay. And then on top of it, you're wondering, I don't think my teacher likes me. And then, God forbid, if you're still in school, all the foolishness that happened in the class before class carries over into your math class. And regardless of how you try to do it. Yeah. Yeah. So when you were first introduced with this, there is so many other factors that played into it. And then now you're thinking, I can't do math. You can do math, right? Okay. Right. So some of it's like, oh, okay, you too, Emilio. Have a good one. Okay, what do you do with the 6? Well, we did the 6. There's 6 B's here. There's 2 B's down there. So 6 minus 2, that's where the B to the 4th came from. Okay, shining star. So a 6 minus 2 gave us 4. 4 minus 3 gave us 1A. Okay. All right, so now that we are more seasoned, not old, we're seasoned, we have more life experience. Okay, good. So now that we have more life experience, now we have more patience with ourselves and knowing that we're not comparing ourselves to other people. You're opening yourself up to learn new things, which is awesome. Okay, that's awesome. So now if some of you guys have kids and they're having problems, you can actually break some of this stuff down. But if it gets crazy, hire me. You know, that's my skill set that I would love to share. Okay. All right. Want to try one more? Okay. Want to try one more? I know, I love when people put on Facebook posts, they're like, well, we're going to do another one anyway. My husband and I, we've tried with our kid and we're looking for a tutor. Who's out there? Like, literally, that was what the Facebook post was. And I was like, hi, I'm your saving grace. So we have a phone call later on today. All right. So we have 7x divided by y squared being raised to the negative 2. Okay. Play around with this first. Take a look at your notes. Play around with it first. Okay. What would you do first? Play around with it. And then we'll work on it together. Sorry, let me zoom in a little bit. Ooh. Very close. Very close. My only question to you will be, what happened to the y? I will see if I can. I'm trying to cut off at 3 o'clock at the latest. If I have time at the end, I'll see if I can do that. Okay, Punk Champion, Bridget. Okay, are you ready for the big reveal? Bridget, why'd you change the answer? Put it back. Put it back! She's like, okay, okay, okay. Close her. I know, we're like obsessed with simplifying. Okay. Aw, that's not nice. Hey, Lynette. Okay. Ready for reveals? Okay, remember I also take question marks. I just want everyone to reveal. Okay? Ready? All right, show me what you got. Your answer, please. Okay, I forgot there's no photo options in here. Thank you. You can tell I was a high school teacher for a while. You guys learn to censor yourself so much. Show me what you got. No, hold on. Please do not. Eesh. All right, and I do take question marks if you're not sure, okay? Or if you're finishing up. Okay. All right, beautiful, Cash. Quiche. Okay, I will take that. Maya, okay. All right, Kimaya. All right. Okay, what's up? Okay. All right, Frank. Well, hello, Frank. All right. Give me a couple more. A couple brave souls. Remember, not Squid Games here, guys. Okay, you're not going to die. Everything's going to be all right. All right, Nancy. Okay, I forgot this stuff. Hey, that's fine. It's okay. Here to kind of revisit. It's fine. All right, so first thing, we have a negative exponent. Let's take care of that. By the way to do the negative exponent, you want to flip. So that is going to result in moving my y squared up here in the numerator and my 7x in the denominator. But that makes this exponent a positive 2. Okay, so we flip these. I know I didn't do this one, but I just wanted to see what you can do. So you are going to flip these to make this into a positive exponent. So now from here, you're going to take your y squared and you're going to square it. Then you're going to take your 7 and square it. And then you're going to take your x and square that. All right, let me shrink so you can see everything. Okay, so we had a negative exponent. So we flipped the ratio, we flipped the fraction. So what was in the denominator now is in the numerator. What was in the numerator is now in the denominator. And by that act of flipping, we were able to change our exponent to a positive. So now we're distributing, or we are raising everything inside this parenthesis to the second power. So y to the second power, that's going to be y to the fourth. Because when you have a power to a power, you're multiplying. 7 squared is not 14. It's 7 times 7, which gives me 49. And then we have our x squared. Okay? So we can't do anything with this y to the fourth and x to the second because they're not the same base. So since they're not the same base, this is my final answer. Okay, so for those that had y to the fourth over 49x squared, good job. Okay, G, yes. Okay, so Frank, you were right there. The only thing you had to do was square the 7 and square the x. Those are the only things that was missing. Okay, buggers. All right. Okay. All right, so we got one more, and then we're going to do scientific notation. Okay, we got some scientific notation. All right, so how crazy should I get it? How crazy should I get it? I'll do a little more nuts. Why not? Let's go nuts, man. So we got -5. Let's slide that over. So -5x cubed y. That whole thing is being raised to the second power over 10 x squared y. And I want that whole thing raised to the second power. What? Do the derivatives? No, we're not doing derivatives. Don't go too crazy. Don't go too nuts. Okay. Just think about it. Take a moment. Raise everything to 0. You're like, and then she threw some fractions in there, and there was radicals, and then there was ratio expressions, and then she drew a cat, and then and there was a donkey in there, and I think there was a sloth. It looked like a sloth. I'm tapping out. I can't do this in my head. Need paper. Yes, paper, definitely. Yes, definitely do paper. Yep. Infinity divided by 0. Yep. Hey. Yep. He had infinity signs in there too. Are you in my class? What's 25 times 25? 625. I love how we all bring our stuff in here. Oh, thanks for the follow. We try to be cool in here. Cool like cucumber. I know, just sitting here, nice and easy. And then 0 was a cross section of the sphere. Conundrum. Look at you. It's all kinds of fun. All right. And if you're sitting and waiting, while you're sitting and waiting, you can tap on the screen. Let's see if we can make this up to like 12K. That would be fabulous. Thank you. Could be a mad tap. Go crazy. It's not like, hey, you can't take the taps with you, people. Just let it all out. Okay, almost there. Thank you. Okay, take your time and walk yourself through this. Okay, breathe. You are no longer a teenager being awkward in the class. You do not have a teacher that doesn't like you. You have a teacher that actually likes you, wants you to win, wants you to be successful. It's okay. You know, and if you're just like, I don't think this is right, still work through it. Okay, try to work through it. That's one thing that we all need to learn. Just work through it. If it's wrong, we'll make corrections. Okay, that's why all these pencils have erasers. Okay, we're all not perfect, but at least the attempt was there, the follow through was there. That is the meaning of life. Got to move forward. Do not let people stop you because you think, oh, I don't think this is right. Go ahead. Now, if you say the answer is mule, okay. And actually, mule is a number, but we'll talk about that. That's like calculus. She's like, what? A mule is a number? I'm like, yeah, not the animal. Okay, sermon. Yes, definitely. Because I think we beat ourselves up so much. And as I say this, I also say this to myself. And it's like we have a tendency to stop doing things because, oh, it's not in line with everyone else's passion and ideas. Psh, screw that. That's the reason why, you know, it's so passionate for us not to lose that. Okay. All right, so pug champion, go. Pong. I keep saying pug. Pong champion. Oh, that was college days. I was pretty decent with the pong. And from there, I plead the fifth. I think everyone has stories about college if they went, or even if they just lived near a college, everyone has a story. Okay. Okay, Petrita. 225x and to the 8th, y to the 6th. Okay. All right. Okay. Ready for the reveal, or do you need a couple more minutes? Okay. Did you get a decimal? I think Bridget is just like, I'm going to throw people completely off. That's okay. Harlequin. All right. Okay, while we were, there were infinity symbols. Yes. Picture of a duck. Chicken feet. All that. All right, so let's get it up to 12K, and then I will go on. We're almost there. There it is. Thank y'all. All right. So now, work from the inside out. Okay? So, first thing, I want to take a look. And I know sometimes people like, the i's go everywhere. So if I cover up that denominator and I'm just focusing on my negative 5, x to the third, y to the second. So that means I have my negative 5 that's being squared. I have my x to the third that's being squared. And I also have my y that's being squared. So I'm just working on what's going on inside. Then my denominator, I can just bring down my 10 x squared y. And all of this was being raised to the second power. Okay. So now, let me work downwards so we can see it. Negative 5 squared. That's the same as saying negative 5 times negative 5. And negative times a negative will give me a positive. And 5 times 5 gives me 25. So now, we have x to the third raised to the second. So when you have a power being raised to a power, you multiply. So this will give you x to the 6. Okay. Y being raised to the second, this is just going to be y squared. Okay. Are we okay so far? All right. Rewrite my denominator, which has my 10, my x squared, and my y. And remember, we had a bracket. That means we have to square everything. Okay, good. So now, let's square everything. So 25 squared. I forgot who asked what that was. So that means you have 25 squared. I'm going to kind of slide it over just a hair. Let's do that, just so I can get some room. So I'm going to slide it over to about here because I'm going to put my answer over here. So we have our 25 that's being squared. We have our x to the 6th that's being squared. And we have our y squared that's being squared. As well as the 10 is being squared. The x squared is being squared. As well as the y. Okay. Eventually, you won't need to do this step. Okay. I'm just showing this step because you want to see where it's all coming from. Okay. So I squared everything that was inside of that bracket. Brackets and parentheses very similar. So now, 25 squared gives me 625. X to the 6th raised to the 2nd. Multiply those, that will give me x to the 12th. Y to the 4th raised to the second, y to the 2nd raised to the 2nd, that will be y to the 4th. See, I'm already thinking ahead. Then we have our 10 squared, which gives us our 100. X to the 4th. And y squared. Okay. So now, okay, we could simplify this, of course, but it'll take us back to that 5/10. We don't want that. So just leave it. Leave it alone. But let's get our x's and y's situated. So if we have 625, we have our 100, x to the 12th, x to the 4th. Isn't 6 squared 36? Yes, but 6 is an exponent. So you multiply exponent to exponent. Yeah, the 6 isn't being squared. It's raised to the second power. It's raised to the square power. Okay, thank you, Bridget. All right, cool. All right, so I will get x to the... So now I'm going to get x to the what power? So what's 12 minus 4? Okay. Good. That'll be x to the 8th. Good. Thank you for the follow. Thank you, Jaden. Thank you. So now y to the 4th divided by y squared. So you're subtracting. So that will give me y squared. Because 4 minus 2 will give me 2. I'll have 2 left in the numerator. Yes. So we can leave it like this. Unless you're Bridget and you divide it and made it into a decimal, which is fine. But most times, at least, they'll probably leave it like this. Okay, come with questions. Come with questions. Okay, so if you divide by 25, that's bringing you right back to the original. We don't need the original. We wanted to know what the square of the square is. So leave it alone. Okay? Leave it alone. All right. Okay. So you can do the 25/4, but you don't want to go back to the 5s and 10s. Which are square roots? Yep. Perfect squares, actually. All right. Okay. Now, as I'm not sure if she's still here or not, but as I mentioned, these were the notes from earlier. If we need to take a picture of it real quick, take a picture of it real quick. And I'm going to do like 2 shots. Okay, so you can take a screenshot of this first one. I can push it up a little bit because I know sometimes the comments get in the way. But I want to finish off doing scientific notations. And then we are done. Okay. Yeah, I was able to go a little bit longer today. A lot longer today, actually. Okay. So, pushing up. Okay. All right. And we got the rules. Let me zoom in for a little bit so you can get the rules. The properties. Okay, screenshot if you want to get the properties. And then moving to the next part. Okay. All right. Okay, so now what we're gonna do next is scientific notation. So here's a question for you. Did you guys know that Google is a number? I mean, you guys, if you knew that Google was a number, go ahead and do it with a thumbs up. If you're like, say what? Okay, yes or no? Did you know that Google was a number? Yes, Bridget. Good. She's like, yay. Yep, so it's It's basically 10 raised to the 100th power. Okay, so let me unzoom a little bit. Oops. Okay, but the proper spelling of Google is not what you're used to saying. So it's Google. Okay, it's not the spelling of the internet. Okay, something new. Yes. Oh, Dolores, were you able to get the screenshot? I'm sorry, because I didn't see you. Okay. So Google is basically a base of 10 raised to the 100 power. Okay. All right. So when you're dealing with extremely large or extremely small numbers, like if you ever worked on trying to see if I can get if you ever put in a calculator and it gives you that error symbol, I'm really trying to think how I can, not really an error symbol, but ooh, it gives you like a continuation. And it gives you like an E at the end of your calculation. Well, that is a way of doing scientific notation. So let me slide this over so you can get this. So when it comes to scientific notation, we're either taking extremely large numbers or extremely small numbers, and we're putting it in a way that we don't have to worry about trying to fit it all on our paper. Okay, that's the best way I can describe it. So, like if I look at, let's say for example, so we have 3, let's go. 2, 3, 4, 5 of those. 6 of those. She's like, what is she doing? 1, 2, 3, 4, 5, 6. Okay. I even gotta shrink it down just so we can see all the numbers. Oh yeah, it's still going. There you go. All right. So we have this extremely large number. Okay. This is called a quint. So a million quintillion. Yeah, something that we all wish we had in our bank accounts, which we can, okay? So, quintillion. So how would you like to multiply or divide by a number like that? No one does. So what we do is we translate this into this scientific notation format, which we have over here. So the first thing that we need to know, that our C, okay, the C value has to be a single digit. It needs to be a digit between 1 and 10. It can include 1, but it cannot include 10. So we're looking at numbers 1 through 9, okay? That is going to be out here. And sometimes you can separate it by a decimal point, all right? So the n is basically an integer. It could be a positive number. It could be a negative number. It even can be a 0. So if I want to write this or translate this lovely, lovely number, I need to come all the way up to here. I cannot say it's going to be 33 times 10 to a power of something. I have to first make it into a decimal. So it's going to be 3.3. Okay? Notice it's at a single digit. Okay? So if I want to, my decimal always start all the way at the end. And basically I'm counting how many. But let's be real. We got them in groups of 3s, right? So we got 3, 6, 9, 12, 15, 18. So that means my decimal point will land here for 10 to the 18th. But I'm not looking at the 18th. It can't be 33 because that's 2 digits. I need for it to be a single digit. So instead of 18, I got to move it over once more. So that will be my 10 to the 19th. So this compacted this into scientific notation. Okay? So it always has to be a single digit. So let's say we have 937,200,000. Okay. So let me ask you, where would the decimal place go? In between what two numbers? Where would the decimal place go? In between what two numbers? So you're saying the 9, okay. So we're saying between the 9 and the 3. Yes, okay. Yep, rigid between the 9 and the 3. All right, 9 and 3, good, film artists. All right. So if I want my decimal place to end up between the 9 and the 3, it starts on the end. So here's 3, here's 6, 7, 8. So my exponent is going to be 8. But what comes in front of it, we can't round, because eventually we're going to need to go from the scientific notation back to this number. So we can't neglect the other numbers that come into play. Okay? You can neglect the zeros, but you're going to need that 2. You're going to need that 7. You're going to need that 3. So like if I want to go backwards, I can say 1, 2, 3, and I'm like, okay, I need to go to 8. That means I need 5 zeros. 1, 2, 3, 4, 5. Okay? So I wouldn't do any rounding. Yes, just leave it as is. So if they ever ask you to write things in scientific notation, if it's a large number, your exponent's going to be positive. Okay? If it's a large number, if it's a positive number, your exponent's going to be positive. But if I take it, let me give myself a little room. So if I have 0 point, 1, 2, 3, 4. where should the decimal point lie when I put it in scientific notation? Between what two numbers for this one? Okay, so Bridge is saying between the 6 and the 8. Is she right? Okay. Between, are you saying between the 8 and the 4? Nicole. Yes, okay. Okay, I need one more answer. Where would the decimal go? Between what two numbers? Okay, all right, thank you. So since we need our leading to be 1 unit, because if I do it between the 8 and the 4, that means I got 68.4. But we want just a single digit. So it's actually going to stop here between the 6 and the 8. So that means I moved 1, 2, 3, 4, 5. And then this will be 6.84. But since we're dealing with smaller numbers, it's not going to be a positive 5. It's going to be a negative 5. So we're saying that, okay, if you start here between 6 and 8, that means I want you to move 5 to the left. Whereas these other ones, okay, you're going to start here between 9 and 3, and I want you to move 8 to the right. Same thing for this one. I want you to start between 3 and 3, and I want you to move 19 to the right. Okay, good. Okay, questions on that one? Okay. So here's a little helpful hint. I'm going to put that into, oops, the steps. So if you have a small number, you're going to have a negative exponent. If it's a large number, you're going to have a positive exponent. Okay, so that's key. How is it negative when we move to the right? We didn't. This is when we're going to translate it. So when we translate it, we're not moving to the right, we're moving to the left to bring it back to this. Okay, so we're not moving to the right. We move to the right to get here, but if I need to translate it back to that, I have to move to the left. Okay, so that's why it's going to be negative. So like if I have this, I had to move to the right to get my original. Okay. 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 All right. So let me do one more and then I have to go. So if I give you -0, let's say, okay, Okay, what would this be as a scientific notation? Good. Okay, keep going with that. So close, Alicia. So close. Just one thing. Actually, and then Bridget, one thing. Okay. All right, so I have to get going. So, yes, the decimal point is going to be between the 3 and the 4. So how many decimal places we went? We went 1, 2, 3, 4, 5, 6, 7. But if you started off with a small number, because it has a decimal, remember, you start off with a small number, you're going to use a negative exponent. So instead of a positive 7, it's going to be a negative 7. So if I needed to translate this back to its original, I can. That means I'm moving 7 places to the left so I can get this original factor. Okay? There you go, Bridget. Okay? So Alicia, do you see what you were missing? Okay, good. Okay. All right, so I don't like to cut things off short. If we can make it to 14K with the likes, I would greatly appreciate it. I'm at negative, but I was driving. Oh, why are you driving? I do not want you to die on the road. No, we already lost an angel because of cars and vehicles and stuff. Come on now. Be safe. I mean, I appreciate you joining in. I really do. But whew, please be careful. Please be careful. Yeah. Because that will hurt my heart tremendously if I heard that you passed on because you were doing math problems. Like, no, we don't want to die because of math. That's crazy. No, we don't want to do it. All right, so I'm going to have to get going. If we can get like 200 more taps, like a quick math tap, I would greatly appreciate it. Also, I will be on tonight at 8:30. I'm going to continue on looking at volume of solids. So I think tonight we're going to be looking at the rectangular prism, the triangular prism, like prisms and pyramids. And if I do have time tonight, I'm going to see if I can do surface area, but I definitely want to do volume. All right, so see the notes. Oops, keep doing that. Let's see if I can shrink. I think that's all the way in. So I might have to do 2 parts. So let me show you this part. Take a picture. And then I'll slide over to show you this part. Okay. She's over here taking screenshots while she's driving. This is not the way that we want. All right. Okay. All right, so this week I'm going to keep with my regular schedule, and unfortunately I'm going to have to cut my hours down because I need to pay mortgage people, and I just got my BG&E bill a couple days ago, and it says $1,000. I'm the only one in this house. So I searched my attic to see if there was like other people living, because you see movies like that, like, oh yeah, I was living in this house for like since 19 whatever. I'm like, what? Because it doesn't make any sense for my BG&E, which is Baltimore Gas and Electric bill, to be, and I keep my thermostat at 72. Ridiculous. So everyone's just trying to go cray cray. So I'm going to have to like cut my hours back, and I'm going to start that next week. So it's going to be like on Mondays and Thursdays, I'm going to do 1 p.m. and also 8:30 on those same days. I'm going to try to fit in like a Saturday, and I'm thinking like a Saturday afternoon. So we'll see how it goes. Okay. So at least we can see each other like 3 times a week. 1, that gives you guys some time for all this stuff to marinate. And 2, I can get a couple paid clients so I can, pay the government. Just work just to pay the government. Yeah. Okay, that's fun. All right. So thank you guys, the 14 that's still here. Thank you so much for sticking. I know it was quite long, but I will be here tonight. And again, I said we're going to be working on volume. And that's 8:30 Eastern Standard Time. Okay. Okay. Thank you. All right. So we'll go through that. Thank you. So I can get you started with that. Okay. Awesome. Thank you guys. Have a great day. Talk with you later on. Bye.